Hello everybody, this is Zareian Jahromi from Power Electrical Developing Advanced Research Group. In this short training video, I'm gonna talk about Matlab simulation file for adapted voltage control in power grids with wind turbine using a STATCOM integration that is shown in the below figure. So if you want to open and run this simulation file like the previous training course, you should go to the Matlab file which is placed here, and please copy this link address here and paste it in your Matlab software by pressing the key enter. You can call all of the simulation file in the current folder of Matlab software. By double click on main simulation file, you can open the simulation and see different part and different aspect of this simulation. As you can see in this simulation file, we have a power system which is modeled by infinitive bus here, and by double click on this block, you can see different variables of this block. Also, by click on the each block, you can see different variable for this simulation. In other part, and as you can see here in this part of simulation, we have a wind farm which is connected to the infinite bus through the 25 kilometer line, which is model P model. And by double click in wind farm, you can see this wind farm consists by 3 wind turbine with capacity of 2 cross 1.5 megawatt capacity. By double click on each block, you can see different parameters of this component and different variables which is set for wind turbine here. Also, as you can see here, a wind turbine receive a wind speed here, and by double click in wind, you can see different changing in the wind in by the time during the operation. Also, by right click on this block and go to mask and look under mask, you can see different component and aspect of the certain wind turbine. As you can see, this is a type 2 wind turbine, which is consist by asynchronous machine and a different component for wind turbine here. And if you back to the another layer of simulation, you can see different component for compensation of wind turbine. As you can see here, we can have a trip order for active and deactive of each certain turbine, wind turbine. Here, so we have a trip function for active and deactive wind turbine, which is defined by variables of W, W1, W2, W3 for active and deactive of each certain turbine. If you choose a 0 or 0 4W, it's used for trip and deactive. And if we want to active this each wind turbine, we can use a 1 for activate of each wind turbine. So we have 3 activation switch and deactivation switch for each of wind turbine which is placed here. So if you look at the simulation, we use a wind farm based induction generator type 2, and the induction generator needs reactive power for operation, for their operation. So in order to compensation of the operation of wind farm, we use a STATCOM, the 3 STATCOM. Each STATCOM can be active and deactive using the switching by parameters of S1 for STATCOM 1, STATCOM 2, and STATCOM 3. So you can active and deactive of each STATCOM by this switch. Also, in this simulation, actually, we want to compare the impact of STATCOM to control of the voltage when a wind farm connected to the power system, infinite bus, and this wind farm needs to compensation and reactive power to operate in a normal operation. So the main goal of this simulation is to uh, compare a state of the uh, operation of wind farm use in without and with and without uh, presence of STATCOM in power system. In order to this goal, we provide you a Matlab code that compare these states that I explained about them. If you open the main code by double click here, you can see the uh, MATLAB code that is provided for you for a study of this simulation in different state of the uh, presence and or non-presence of the wind turbine or and STATCOM. So as you can see in this MATLAB code, is open a menu here. By run this file, open a menu for you, and you can active and deactive for uh, switching of W and S. By changing these state, you can active and deactive the wind turbine and STATCOM for each scenario. Also, at the end of this MATLAB code, the MATLAB simulation compare the uh, state of the voltage for in presence and non-presence of the STATCOM in power system. For example, if you run this simulation, you can see the program asks you for a number of the wind turbine that you want to be active in simulation. For example, I want to this simulation with maximum wind turbine. So in default, I don't change it. I want to have maximum three wind turbine for to be active in simulation. And also I want to compare the effect of the STATCOM with maximum power and maximum capacity and maximum number of the STATCOM in power system. So I don't change the default of this simulation, and I want to compare the system in affection of the 3 STATCOM. So choose 3 for number of STATCOM. Also, I want to have a simulation for 100 seconds. Also, by press the OK enter, another menu asks you about the compare affection in with and without affection of the STATCOM in power system. So if you choose the yes, you can see the result for comparing the operation of the power system in affection of the consideration of impact of the STATCOM and without consideration of the impact of the STATCOM. By press the yes, and just please wait for simulation is finished and get result by the simulation. If you wait for several minutes, you can receive and see the result during this operation of the uh, case study by consideration of the STATCOM and without consideration of the STATCOM effect in power system. And you can see impact of this STATCOM on power system and on voltage control of the system. So if you look at the simulation result, for example, if you open this simulation, first figure is related to the voltage at bus 25, as you can see here. We can see the voltage, RMS voltage at bus 25. Here we have a voltage at bus 25 in with dash line and solid line. As you can see, the green solid line is related to the uh, consideration of 3 STATCOM and 3 wind turbine. Also, you can see the voltage profile of bus 25 without consideration of the STATCOM. So as you can see here, the voltage is received to the stable point, and uh, the voltage is a stable point in presence of the 3S STATCOM. Also, you can see the current of the generation, and another point that is that you can see here, the voltage is stable and achieved to the without any chattering when it achieved to the stable point and reach to the uh, standard value of the voltage for bus number 25. Also, another figure is related to the active and reactive power, which is uh, injected by wind turbine to the power system. As you can see here, the active power don't have any chattering and don't have any fluctuation. The voltage is stable during the operation of the system. Active power is stable during the operation. Also, in another part and in another curve of the simulation related to the dash line when without a STATCOM, the active power has many fluctuation on it, and as you can see here, the fluctuation can this fluctuation can be uh, has a bad effect on frequency. So if you study the frequency, you can see instability on frequency without consideration of the STATCOM. So it shows the big role and crucial role of the STATCOM during the operation of the system. Also, this issue can be uh, see in a reactive power when a reactive power in presence of the STATCOM is stable and without chattering can be continued by the power system study. So you can see another parameters of the system for active and reactive power of the wind turbine and active and reactive power of the STATCOM. Also, you can see voltage and reactive power which is injected by STATCOM to the power system can be seen here, and you can see the uh, action and reaction of the STATCOM into the power system in order to control the voltage and the stability of the power system during the operation. So this is a simple example, can be uh, can be modified by you, and you can work on it with your goal of your project, and you can modify and develop it in order to uh, complete it for your projects and different goals that you have in your projects. If you want to uh, if you want to download and uh, save in save this simulation file in your project, just go to our Power Matlab channel in Telegram with the below address, with this address, and you can see download it for your projects and your desired uh, project that you want to accomplish them during your studies. So you just go to our channel and download different thousands of the simulation file which is provided for you. Many thanks for your attention and stay tuned. Bye for now.